Simple harmonic motion. Simple harmonic motion is a different sort of motion compared with, say, linear motion or circular motion. And we're going to have a look at some examples and what exactly makes up simple harmonic motion. So a simple pendulum is an example. Perhaps this is not a terribly good one. This one, more or less, is simple harmonic motion, but not a really good one. This one here is a bit better, where we've got two beekeepers having a bit of fun on a swing. So it shows all the characteristics of simple harmonic motion. But this one here, again, shows the characteristics of simple harmonic motion. And one of the key features is that it is periodic. That is, it's repetitive. It goes again and again and again and again and can put you to sleep. But the other thing about it too is that it traces out a sine curve, or if you prefer, a cos curve. This oil pump is another example of simple harmonic motion, or at least the arm that is going up and down. You can see that it is periodic. It involves acceleration, it involves velocity, displacement, and you can see the connection there too with circular motion, and we'll be talking about that later. The operation of a steam train, the piston that you can see here that goes backwards and forwards, that's an example of simple harmonic motion. There is, in a way, an equilibrium point about which this piston moves. And you can see again here, there's a connection with circular motion. The ordinary automobile or car engine shows simple harmonic motion when it comes to the piston. The piston there going up and down, backwards and forwards. That's an example of simple harmonic motion. If we have a look at the shadow of a Ferris wheel, just take one carriage and look at it moving backwards and forwards underneath as it turns around, we find that that shadow moves in simple harmonic motion. It gets slower, 0 velocity, faster, 0, faster, 0. It's accelerating towards the center, and again, that's repetitive. It's simple harmonic. Now, this particular graphic here shows you in more detail the features of simple harmonic motion. First of all of these examples have what we call an equilibrium position, a spot in the middle where the object might normally rest. But what's happened is that it's been sent moving, and as it moves away, as it experiences displacement from its rest position, it experiences a force. And that force is normally called a restoring force. And you can see up here, the red arrow shows that that restoring force always brings or tends to bring the mass back to its equilibrium position. The other thing to notice is the displacement. The displacement always has a direction that is opposite the restoring force. Now, what that also means when it comes to the force is that the acceleration is always in the opposite direction to the displacement. So those are the key features of our simple harmonic motion. To summarize, the characteristics of simple harmonic motion are that it is periodic or repetitive, that the force responsible for the acceleration always acts towards the rest position, or the equilibrium position. The restoring force always acts in the opposite direction to the displacement. The restoring force is directly proportional to the displacement. That is, F, the force, is equal to minus kx, where x is the displacement and k is the spring constant. That minus in front of the k is an indication that the displacement is in the opposite direction to the force. So our last example is this simple spring going up and down around its rest position. It's accelerating constantly towards the equilibrium position, and the restoring force is in the opposite direction to the displacement.